one of the troubles that U substitution noobs have when using U substitution is knowing which things you would set U equal to. So which of the following integrals is a candidate for U substitution? A, B, R, and C is not. This one is, and this one is. This one is not. Okay?
Why not?
Well, we're going to talk more about why not in depth on number 2. So let's go to number 2. This one says, find an appropriate choice of U for evaluating the following integrals by substitution. Now, the way I think about this, and this works most of the time, I would say 85% of the time this method works. I look for the function that is most inside, like the function that's buried inside of the bigger function. So when I look at this one right here, I have a function right here, it's just x, and this guy right here, and then this is inside of the fourth power, which is another function, like an operator. So for this problem, u would equal x squared plus 9. And then, so now your question is, well, how do you know for sure? What you do is you take the derivative of both sides of your little equation that you made to see if there's an easy substitution that's going to happen. Okay, so what's the goal in U sub? The goal in U sub is to get rid of all the x's, including the dx, and use u. Because if you do that, then the problem, the integration, will look a lot simpler. So this is how you can know if this u works. First, take the derivative. So what you're doing is you're taking the derivative of both sides with respect to x. So it looks like this. I'm writing extra here just for explanation purposes. And you have to remember how to take the derivative implicitly. So like if I take the derivative of u with respect to x, that would be 1. But then I would have to use u prime. But I'm not going to write u prime. Instead, I'm going to write du over dx. This is a huge differential equation thing. We don't use u prime in differential equations. We use du over dx because it's extremely valuable. Now we have the derivative of this side, which is just going to be 2x. The derivative of a constant is nothing. It's 0. So I don't need to write this one right here. Let's erase that. What you do next is it looks like you're multiplying both sides by dx. You're not really doing that, but it looks like it. So we're going to write du equals 2x dx. It's almost like we just multiplied this side by dx, and these would cancel out, and you multiply this side by dx. Okay, so these guys right here are what you would use to do your u substitution. So this is, and I'm not going to finish this. I'm just checking to see if the u is good. You would be able to do this part in your head. Now see this 2x dx? You guys see the x dx? Yeah. There's an x and a dx right there. So this means you would be able to take out this x and this dx and put in this du. And actually, since we're so close, let's go ahead and finish this. We're so close to doing this, and it's good review. You guys need to see lots of practice here. So let's substitute those x's out and put in the u's. Let's first start with just this u right here. Let's get this u into this integral. So then you're going to, oh, that's a nice integral. We're going to take out that x squared plus 9 and put the u in its place, keeping the parentheses just for explanation purposes. Now I just did one thing. I didn't want to do two things at once. I have this u in there, but there's still an x there and a dx there, and I don't want them. Now we do need to have a du in here, so that's when this guy comes in handy right here. So what we're going to do is, oh wait a second, that says 2x dx. Do you guys see a 2 up here? No. Okay, so let's get this 2 over to this side with that du. How would you do that? Divide by 2. So if I divide by 2, that would go away, and I'd be left with the dx there. On this side, I'm going to write 1/2 du. Okay, don't get tripped up over that. It's instead of going du divided by 2, I'm going to write it as 1/2 du. Same thing, just writing it differently. Now I have an x dx. All right, there's the x dx. Now there's an x dx right here. I can just take this x dx out and put in the 1/2 du. Now, I'm going to write extra even more so just because I want you guys to see what I'm doing. I have this u to the fourth, and I'm going to put this x right next to my dx. That is what I'm going to take out. And in the x dx slot, I'm going to put 1/2 du. So let's take out this this guy right here, and we're going to put in what it equals, 1/2 du. Shh. Now I'm just going to input it straight up so you guys can see it. But normally, I wouldn't put the 1/2 right here because that 1/2 is a scalar. And you can take out scalars. You can put a scalar in front of the integral sign and then do your integration. So I would have written it like this when I wrote it down. Wow, that's a nice integral sign. And we have u for, and then du. Okay, so this problem right here is the same as this one. This one looks way nicer, doesn't it? Now you do your antiderivative and you're done. That's it, people. You're done. Okay, so add 1 to the 4. So you get u to the 5th. And then you have to divide by 5. And then you would do plus c. Don't forget to multiply this by 1/2.
Wait, so du?
Now, I don't like having the 5 on the bottom usually. I normally would write 1/5. But, I don't know. In this case, I suppose it works. We have u to the 5th over 10 plus c. Now this isn't finished because I can't have the u in there as my final answer. So what does u equal? What is u, people? X squared plus 9. U is x squared plus 9. Who learned you to spoke? Okay, so we got plus c. This would be the answer to this integral. Now you didn't have to do that. This just wanted you to identify the appropriate choice for the u. The appropriate choice for this u is x squared plus 9.